Hello everyone. So today I'll be discussing the question that came into LeetCode weekly contest 380, and the question is maximum number that sum of the prices is less than or equals to k. You will be given two integers k and x, and we need to consider a string s with one based indexing with a binary representation of an integer num. The price of a number num is the number of indices such that the index I is divisible by x as well as having a set bit. So we need to return the greatest integer m such that sum of prices from 1 to num is less than or equals to k. So basically I need to find the greatest integer that I can afford so that the summation of all the integers that are coming in the range from 1 to num and the sum of prices of all those integers should be less than equals to k. So if we look at the constraints, that is 10 to the power 15. So maximum value that we could afford is 2 to the power 50, that is greater than 10 to the power 15. Like the maximum number of digits we can have in the binary representation is 50, because 2 to the power 50 is greater than 10 to the power 15. What if I write it? That is, I'm taking 2 to the power 50 is greater than 10 to the power 15. So I'll be starting from the 58th position. Now for each position, like I'll be having one, two, I'll be having one and two, then three. Let's write it in the opposite manner, like 50, dot, 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 8, 7, 6, 5, 4, 3, 2, 1. Now for each position, I need to consider whether I could put 1 over here or not. Because if I put 1 over here, then that's the maximum integer. So our goal is to check whether I could put 1 or not. How could we check that? So for each position, basically I need to check whether I can put 1 or not. To put a 1, I need to calculate the total place, total price when there was 0. Like if a certain position has 1, then I need to calculate what was the sum of price when that position was 0. So to fix 1, to check whether we can put 1 or not, we need to calculate the number of price, not the number of price, the sum of price when that position was 0. For that, let's take an example. Let me drop it. I'm taking for 8 positions now. Let's take from 8, 7, 6, 5, 4, 3, 2, and 1. Now, as well as I'll be taking that x is 2. Now the positions that are valid is 2 because 2 is divisible by x, then 4 again, 6 and 8. These are the valid positions. Now for this position, if I want to check whether I can put 1 or not, so how much the price was when there was 0. So let me fix 0 over here. Now 7 6 for 7, this is for 6, 5 4 3 2 1. Now I have fixed 0 to the 8 position. Now how much 1 that I can have from these positions 6 4 2 that are right to the current position. Now if I want to find out for only 6, that how much 1 it will have if I have fixed 0 to the 8 position, then I'll be fixing 1 to this. Now I am left with 1 2 1 2 3 4 5 6. There are 6 positions that are left. So the number of ones that it will be contributing is 2 to the power of 6. Yeah, because I have 6 positions. So this will be 2 to the power 6. And for 4, 2, 6, for everyone is 2 to the power 6. Like how much ones it they will be contributing to our answer. Now I have calculated for the right positions. Now if I want to know for the right, like I have calculated for the right position. Now if I wanted to calculate for the left one, how could it be? Let's say I already have fixed 1 over here, then again 1 over here, 1 over here also, 0 over here. Now I am standing at position 4. Now I want to check whether I could put a 1 or 0 over here. And my goal is to calculate the number of ones that could be generated from my left side using this positions. So the valid position for me is 8 and 6. 8 and 6 are the valid positions for me. So I want to calculate if I put 0 over here, then how much ones 8 and 6 will be generating. So I have 3 positions left. So can it be generalized in the form of 2 to the power of current position minus 1? Yeah, my current position is 4, so 2 to the power 4 minus 3. And for the right one, into the right valid position. Because for 8, it's 2 to the power current position minus 1. And for 6th position also, so it's left valid position into this. Mm, left valid positions into the 2 to the power current. And for right also, if I want to generalize it, it was 2 to the power of current position minus 2 into current position minus 1 divided by x. Like if I am standing at 8, then how many valid positions I am having is 8 minus 1, that is 7 by 2, that is 3, 6, 4, 2 are the valid. So that is okay. So for the right one, this is my thing, and for the left one, this is my thing. This is for the left, this is for the right. When the current position have 0. Now, what if I want to put 1? Is there any possibility to put 1? Like I have calculated when it has a 0. Now, when it has a 0, now I want to put 1 over here. Now, the minimum number that I can generate by putting 1 is, if I want to put, then the minimum number that would be generated would be 0, 0, and again 0. Because these are the fixed. I have already fixed these numbers. So I'll be putting 1 over here and those zeros. So again, what this minimum number would be contributing to our price? That is the left valid positions. So if I want to write the extra for checking, extra terms, what it will be? Left valid positions plus 1 if current position is divisible by x. Then only I'll be adding 1, because this one will also be contributing. If I want to check for the third position, then this will not be contributing to my answer because this is not a valid index. So if the current index is divisible by x, then only I'll add 1 to my answer. So this is clear, like for the left, for the right, and extra terms. So let's move to the code. That will be more clear. So what I've taken left. So this is not needed, and the sum and answer. Like if I'm standing at position I, then the remaining position to my right is I minus 1, and then 2 to the power of remaining that I have stated over here, that is 2 to the power of current position minus 1 over here. Then my right, here I'm taking, this is at the right. Actually, this is the left, and this is at the right. So this is nothing but 2 to the power of current position minus 2, because I'm like this is 2 to the power of current position minus 1, and I'm dividing it by 2, it means that is 2 to the current position minus 2 only. So I'm multiplying it by right, that is the right term, and this is the left term, and this is the previous sum. Means like I have already fixed these integers, but what was the sum when these integers were 0? Like this was 0. So that was the previous sum, because I have already fixed 1 to this. So what was the sum when this indices were 0? So this one is the previous sum, and I'm adding left. Like the if I wanted to have the 1 to my current position, then the extra terms I need to check for that. If the current position is divisible by x, then the total should be exceeded by 1, and also the left position, because the current position is divisible by x. So I'm just adding 1 to this. Now, if the total that I'm having now is less than equals to k, like am I be able to put one over here or not? If the total price that I'll be getting if I wanted to put one over here is less than k, then yeah, I wanted to find the maximum answer. So I'll be put one over here. So I'm doing the same thing like answer or I minus one because it's a zero based. So I'm doing or with one. And now my sum would be total minus left. Why I'm doing total minus left? It's because I'm reducing those extra terms. Why I'm reducing those? Because I am just assuming am I be able to put one over here? If what are the condition to put one? Like it should be able to accept the lowest term. But I don't know what are the numbers that I'll be putting over here. So that's why I'm reducing those extra terms. From that, I'm just considering the case 0 over here and I'm fixing 1 over here. So for the case of 1, I'm not adding anything to my price because these terms will help me to calculate those price. So I'm just adding the price when the current position was having 0. So that is the total. And if the total is exceeding k, let's say I'm standing at position 4. This is divisible by 2. Now, if I wanted to put 1 over here, then the total value is exceeding k. So I won't be able to put 1 over here. So if I will not be able to put 1, then I'll be reducing the left one because I'll be fixing that position with 0. And there is no need to modify any answer because I'm just fixing it with 0. So I don't know what these remaining terms will be. So if I were fixing 1, so I need to calculate um, those prices that will be contributing when there was 0. So adding that's why I'm modifying my sum, and then I'm just returning the answer. So the basic idea was whether I can put 1 over here or not. To put a 1, I need to calculate what was the price sum of prices when that position was having 0. So I've calculated for the left, for the right, the previous sum, and the uh, minimum price that will be having if I put 1 to the current position. Then I'm exceeding if the current position is divisible by x. And then just checking. If it is less than k, okay, I will be able to put 1 over here. And then I'm just modifying my sum. And if I won't be able to put 1 to my current position, and this is a valid position, then I'm just reducing a left because I have already exceeded this. And then just returning my answer. So that's it for the video.